Welcome back to our Chapter 1 Limits and Continuity topic on our basic calculus class. This time we're going to talk about infinite limits. So, this is the fourth lesson for this quarter. So, our objective is to illustrate and evaluate limits. First, let us check and observe this given graph. Let f be a function defined by f of x equals 1 over x squared, and observe the values of f as x approaches 0. So as we approach 0 sa atong x, observe ang sa nahitabo sa atong y. So here, this is the origin where we can find the x. The value we have 0. So as you observe, kung imong tan-aw ng atong y, sa meto makita. Notice that the graph of f is asymptotic. So in this side, bisan nagkaduol siya sa 0 nga x, pero wala siya ning cross, ning intersect, but nagkaduol lang siya sa linya or y axis, pero never siya nga ning cross, indicate closer and closer lang siya. And the other side also, as you observe. Okay, also observe that the values of f become larger and larger. So from here, so then nagkaduol siya sa value nga x equals 0, ang ato pong y or atong f, nagkadako pod ang iyang value. So we know this is a positive side. So 1, 2, 3, 4. So it reach sa pay pinakadako diha. So larger and larger as x takes the values close to 0. To represent this increasing behavior of the values of f, we will use the symbol positive infinity. Take note, increasing, so we need to use the symbol positive infinity. Thus, we say that f increases without bound. So f increases without bound, without limit. So it continues as x approaches 0, and it can be written as limit of 1 over x squared as x approaches 0 equals positive infinity. So we have the next graph. Now let us slightly modify the function and consider the resulting function defined by g of x equals negative 1 over x squared. Kaganina, we have positive 1 over x squared. Now we have g of x equals negative 1 over x squared. So in contrast to the behavior of the values of f, notice that the values of g compared kaganina ang karon lahi. So ang values ni g becomes smaller and smaller as x becomes closer and closer to 0. So, sadang magkaduol ta sa x equals 0, ang iya pong value nagkagamay. Since this is the negative side, so the greater the value of the negative, the smaller the value. So, in this side, nagkagamay, dito po sa pikas, nagkagamay. So, the graph of g is also asymptotic to the line x equals 0. Therefore, kagay nina, we have increasing. Karon, we say that g becomes what? Decreases without bound. So, it will extend down here. So, without bound as x approaches 0. So, to represent this decreasing behavior of g, we use the symbol negative infinity. Kaganina, we have positive infinity. Now we have the negative infinity. And we write limit of negative 1 over x squared as x approaches 0 is equal to negative infinity. Now the limits that we have discussed are called infinite limits. So we have positive infinity and negative infinity. So we call this infinite limits for obvious reasons. So it must be remembered that positive infinity and negative infinity are just symbols that represent the behaviors of a function. So symbols lang sila, nagrepresent siya sa dagan sa values of function. So as you observe, kung positive infinity, it will increases without bound. Negative infinity sa decreases without bound. And it must not be treated as numbers. So kaning positive infinity or negative infinity, they are not numbers. They're just symbols. Okay? Now, we need to define infinite limits as follows. So the definition. So let f be a function defined on some open interval containing the number a except possibly a itself. So ato na siyang ila-ilahon. We are going to find the limits. Kaganina we talk about the graphs. Now let's have the definition. First, f increases without bound as x approaches what? A, which is written as limit of f of x as x approaches A equals positive infinity. Kanos aman, if the values of f get larger and larger as the values of x become closer and closer to A. So, positive infinity siya kung ang value ni y or ni f nagkadako sa dan nagkaduol kita sa A. Is the value of x become closer and closer to A. So, kung nagka-decrease, we have the second definition. F decreases without bound as x approaches A, which is written as limit of f of x as x approaches A equals negative infinity pod kung ang values ni f nagkagamay, getting smaller and smaller as x become closer and closer to A. Okay, I hope klaro. So, increases without bound, positive infinity. If ang value ni f nagkadako, so diyang nagka-closer and closer ta kang A. The other hand, pod, negative infinity siya kung ang value ni f nagagamay as x become closer and closer to A. Note that we can also have an infinite limit even if x approaches a number from only one direction. So that is the definition. Now let's talk about the theorem. Theorem 1.4.1. Take note. Let R be any positive integer. So ito yung namduman ha. Ang atong R is any positive integer. So it must not be negative. Yung R kani, the exponent. It must be any positive integer. So first, limit of 1 over x to the power of r as x approaches 0 from the right side, that is positive infinity. Pambalikon, limit of 1 over x to the power of r, where r is any positive integer, as x approaches 0 from the right side, that is, the limit is positive infinity. The second one, limit of 1 over x to the power of r as x approaches 0 from the left, natay duha ka answer, depende sa condition. If ang r is even, so we have positive infinity. If ang atong r is odd, bungkig, we have negative infinity. So, akong balikon. Pag ang atong limit of 1 over x to the power of r as x approaches 0 from the left side, if even ang r, ang exponent, we have positive infinity. If odd, we have negative infinity. So we have some examples. Letter A, limit of 1 over x to the power of 9 as x approaches 0 from the right. So take note, our r here is what? Katong tan-awon ang atong R is 9. Ah? And then we have 0 from the right side. So, kani palaman mailhan na nato nga ang answer ani is positive. 0 from the right side. The answer is what? Positive infinity. Okay? For the second one, limit of 1 over x to the power of 13 as x approaches 0 from the left. So we have two conditions. Take note. Pag atong r is even, we have positive infinity. If it is odd, we have negative infinity. So here, limit of 1 over x to the power of 13 as x approaches 0 from the left. So our r is 13, which is what? An odd. So therefore, the answer is negative infinity based on this description or definition rather, that if our r is odd, so we have negative infinity. Next example, limit of 1 over x to the power of 6 as x approaches 0 from the left. So our r is 6, which is even. So we have positive infinity. Okay? So this theorem will work only if our numerator is 1 and denominator, we have these cases. So that is theorem 1.4.1. Now we have 1.4.2 theorem. Take note, let limit of f of x as x approaches a equals c, and rc is not equal to 0. And limit of g of x as x approaches a equals 0. So our z of x, the limit of that must be 0. So first, limit of f of x over g of x as x approaches a equals positive infinity if c is greater than 0. What is our c? That is our f of x. That is our c. Must be greater than 0. Tapos, ang atong g of x, the denominator, must be a 0 from the right. Greater than 0 ang atong c, the constant. Tapos, ang atong denominator is g of x as approaches 0 from the right side. Or pwede po siya positive infinity if our constant is less than 0. Tapos our g of x approaches 0 from the left. So that could be for positive infinity. The second one is limit of f of x over g of x as x approaches a is equal to negative infinity if our c is greater than 0. So the same sila sa first condition, pero magkaiba sila sa g of x because here is approaches 0 from the left side. Ang number 1 from the right side. Or we have c is less than 0 and our g of x approaches 0 from the right. So that could be our negative infinity. Take note that the g of x approaches 0 from the right and g of x approaches 0 from the left, mean that the values of g becomes closer and closer to 0 through positive and negative values, respectively. In this theorem also valid, even x approaches a is replaced by x approaches a from the right side or x approaches a from the left side. So let's have some examples here. So observe carefully. Letter A, we have limit of 2x plus 1 all over x minus 3 as x approaches 3 from the right side. So here, limit of 2x plus 1 as x approaches 3 from the right side over limit of x minus 3 as x approaches 3 from the right side. Proceed. So limit of 2x plus 1, just substitute the value of 3 here. Diba? So if you're going to answer this one, okay, so the limit of 2 is 2, the limit of x is the value of a, which is 3, then plus 1. So this is equals 7. In the denominator, the limit of x is 3 minus 3. So the answer here is 0. Before, in the previous lesson, we can directly say that the limit does not exist. But here, we can see if is this positive infinity or negative infinity ang iyang limit. Now, the denominator becomes 0. Take note that in the definition above, here, RC must not equal to 0. And take note, RC here is 7. 7 is greater than 0, right? So in the first one, we have C must be greater than 0. The second one, we have C greater than 0. So arita mag-check kung asa dapita aning duha para ma-determine nato is it positive infinity or negative infinity. So how you are going to check that one? So balik ta diri, tan-aw na to ang atong A. Remember, we have 3 from the right side. So nangita kag value closer sa 3 pero greater niya. Mo'y atong i-substitute diri sa x. Pag kung i-minus ganing nimo, ang resulta is greater than 0. So, we got 0 from the right. So, 0 from the right, we have this one. Okay? So, our limit will be positive infinity. Pero 0 from the left gani, so our limit is negative infinity. Kano sa ka mag 0 from the left? Kung ang atong value nga gi-substitute diri pag makuha na atong answer ma-negative. Pag positive ganing we have 0 from the right. So let us check. We have x minus 3 and we will use x. Ngita kag value ni x. Take note, we have from the right na. So mangita kag value nga closer kang 3 gikan sa right. So kani ato indicator. If it is from the right, so greater than 3. So let us use 3.01. So equals 3.01 minus 3. The answer is 0.01. And take note, 0.01 is greater than 0. Therefore, we got g of x approaches 0 from the right. Claro? So therefore, we have here 7 is greater than 0. And we have here g of x approaches 0 from the right. So the limit of this one, 2x plus 1 all over x minus 3 as x approaches 3 from the right is what? Baliktad diri. So in the first case, if c is greater than 0, so 7 is greater than 0, so okay siya. G of x and g of x approaches 0 from the right, which is the result of our solution. So therefore, the limit of this one is positive infinity. Okay, kung balikan, first is you need to identify if the numerator, the value or the constant must not equal to 0, and if greater than 0 or less than 0. Then next, if the denominator is 0, from here, identify nato if it is from the right of the A. So mangita kag value na A nga closer kang A from the right. So here happen our value is the value of A is 3 tapos from the right, so I choose 3.01 which is greater than 3. Then substitute lang na nimo sa value sa x, so I get here 0.01, and then which is greater than 0. Like natapag greater than 0 gani. So we have 0 from the right. The next one is limit of 4 minus 3x all over x minus 7 as x approaches 7 from the left. So we get limit of 4 minus 3x as x approaches 7 from the left all over limit of x minus 7 as x approaches 7 from the left. So the numerator, we get the limit of 4 minus 3 times 7 equals 4 minus 21 equals, the result of 4 minus 21 is negative 17. And then, narita sa denominator, so we get x minus 7. So, substitute lang itong value ni a. So, using the limit theorem, so we have 7 minus 7. So, this is 0. Now, our numerator is negative 17. Negative 17 is less than 0. So, here na ba? Yes, in this case, we have this one. C is less than 0 in both cases. So, let us find out our denominator, our g of x. So, we have x minus 7. And then 7, our a is 7 from the left. So, meaning less than 7. So, I will choose x is equal to 6.99. So, substitute na to, 6.99 minus 7, which is equal to negative 0.01. And take note, negative 0.01 less than 0. Therefore, our g of x approaches 0 from the left. So, okay. So, g of x approaches 0 from the left. So, asa man diri a. So, RC is less than 0, right? And then our g of x is approaches 0 from the left. So here, c is less than 0 and approaches 0 from the left here. So the answer is what? The limit is positive infinity. So first, get the limit of the numerator and denominator. Next, determine if our numerator, the constant, is greater than or less than 0. Next, our denominator. Identify if it is from the left or from the right of 0. We are going to find the g of x approaches 0 from the left or from the right. Then after that, so you're going to determine if it is from the left or from the right. So observe, for example, here, 7 from the left. So the value must be less than 7, closer, but less than 7, the value of x. Substitute lang nato sa given expression. Then if it is negative, so that is less than 0. So 0 from the left side. Okay? Then balik ta diri kung mo fit siya ay any conditions dire, so you can answer now. Is it positive infinity or negative infinity? I hope that is clear. The next theorem is theorem 1.4.3. If limit of f of x as x approaches a is equal to positive, negative infinity, and limit of g of x as x approaches a equals c or constant, then the limit of f of x plus g of x as x approaches a is equal to positive and negative infinity. So kung balikan, pag ang limit sa f of x is positive or negative infinity as x approaches a, and the limit of g of x is equals constant as x approaches a, so the limit of f of x plus g of x as x approaches a is equal to positive negative infinity. Note that theorem 1.4.3 is also valid if x approaches a is replaced by x approaches a from the right or x approaches a from the left. So let us try this example. Evaluate limit of 2 over 5 plus x minus 1 over x squared as x approaches negative 5 from the left. So we need to find the limit of these two terms. Then atong i-check sa given condition. First, we have limit of 2 over 5 plus x as x approaches negative 5 from the left plus limit of x minus 1 over x squared as x approaches negative 5 from the left. So limit of 2, so 2 over 5 plus, substitute na negative 5, we get 5 plus negative 5. So limit of x minus 1, so we got negative 5 minus 1 over x squared. So the square of negative 5 equals 2 over 0 plus negative 6 over the square of negative 5 is 25. So we get here 2 over 0 minus 6 over 2 over 5. Take note, we have 2 over 0. From the previous theorem, we need to identify, is this 2 over 0, the limit is positive infinity or negative infinity? Okay, let us check. 2 is greater than 0. So our C is greater than 0. Now let us check with our denominator. So here we got what? 5 plus x. 5 plus x from the first term. And then, take note we have negative 5 from the left. So that is less than negative 5. So our x will be equals to negative 5.01. Diba? That is less than negative 5. So equals 5 plus negative 5.01. So the answer is negative 0.01. So meaning our g of x approaches 0 from the left side. Therefore, our 2 over 0, wherein 2 is greater than 0, and then our g of x approaches 0 from the left. So, kasama na siya, greater than 0, tapos approaches 0 from the left. So, here, greater than 0, but we have what? From the right. So, the other one, greater than 0, tapos approaches 0 from the left. Negative infinity. So, we got here, negative infinity. So, going back, we got negative infinity. Tapos, ang isa pod is negative 6 over 25. So, balik ta dire. If limit of f of x as x approaches to a is equal to positive or negative, check ta. is positive or negative. So, negative infinity. Tapos, our g of x is equal to a constant. So, negative 6 over 25 is a constant. Therefore, our limit must be what? Positive, negative, infinity. So, the answer here is what? Our limit is negative infinity. Because our limit here, kanila to tanaw na pag negative ata diri, so take note nag-ingon ganina pag positive or negative infinity, tapos we have a constant for our g of x here. So you have positive, negative infinity. So since we have negative infinity here, our f of x, so we got negative infinity. Our limit for 2 over 5 plus x minus 1 over x squared as x approaches negative 5 from the left. Okay? So let's have the last theorem. Let limit of g of x as x approaches a is equal to c and our constant is not equal to 0. So meaning it can be positive or negative. Basta dili ka equal sa 0. So first, we have limit of f of x times g of x as x approaches a is equal to positive infinity siya kung ang limit ni f of x here is positive infinity. And our c, which is our g of x, must be greater than 0. So, positive infinity siya, ana, guys. Or if ang limit ni f of x as x approaches to a is equal to negative infinity, tapos our c is less than 0, so we got positive infinity. For the second one, limit of f of x times g of x as x approaches a is equal to negative infinity if the limit of f of x as x approaches a is equal to negative infinity, tapos RC is greater than 0. Tapos, pwede po if limit of f of x as x approaches a equals positive infinity, tapos RC is less than 0. So take note kaganina, we have the addition and now we have the multiplication. So akong balikon, case number 1, positive ang infinity if our limit of our f of x is positive infinity, tapos our limit of our g of x is, or the constant itself, is greater than 0. Pwede pod og negative infinity our f of x, ang iyang limit, tapos ang constant, the g of x, the result, is less than 0. The second one, pag reverse, negative infinity siya if our f of x is equal to negative infinity, tapos ang c nato is greater than 0. Also, if our limit of f of x is positive infinity pod, tapos our c is less than 0. So, let's apply. Letter A, evaluate its given limit if it exists. Letter A, we have limit of 3 over the square of x minus 4 times x squared minus 2 over 5x as x approaches 4 from the left side. So, based from the theorem, we need to find the limit of our f of x tapos the constant of our g of x. Then, atong itandion niya kung asa siya, is it positive infinity ang limit ani or negative infinity based upon the given condition. So first, let us have the limit of this one. 3 over the square of x minus 4 as x approaches 4 from the left side times the limit of x squared minus 2 over 5x as x approaches 4 from the left side. So we got 3 over 4 minus 4 times 4 squared minus 2 all over 5 times 4. So we get 3 over 0, right? times 16 minus 2, we got 14 over 20. So since our f of x is 3 over 0, so take note R3 is greater than 0. Let's check with the denominator. So our denominator is the square of x minus 4. And R4 here, our a is as x approaches a from the left. So we got x equals 3.99 from the left, less than 4. So we got 3.99 minus 4 squared. So the result is negative 0.01 and its square is equals to positive 0.0001. So take note, this is what? Greater than 0. So therefore our g of x approaches 0 from the right. So atong balikon ang 1.4.2. RC is greater than 0. Tapos positive ta atong g of x as approaches 0 from the right. So we got positive infinity. Okay, so we got positive infinity. So continue ta dire. So equals, we get positive infinity na. And kani 14 over 20 can be reduced to 7 over 10, right? So we got 7 over 10. Then balik ta diri sa atong theorem. We have positive infinity for f of x. Tapos RC is greater than 0, which is 7 over 10. Therefore, our infinity or our limit here is positive infinity for this given. So the limit of 3 over square of x minus 4 times x squared minus 2 over 5x as x approaches 4 from the left is positive infinity. Now for letter B, mao gyapon tong buhaton, find the limit in its terms. So limit of 3 over x plus 2 as x approaches negative 2 from the left times limit of square root of 2 minus x over x squared minus 1 as x approaches negative 2 from the left. We get 3 over, what is our x? Negative 2 plus 2 times square root of 2 minus negative 2, right? Our x over negative 2, the square of negative 2 minus 1. So we get here 3 over 0 times square root of 4 over 4 minus 1. So 3 over 0 times 2 over 3. Our c here is greater than 0 na. So, arita problema ron sa atong f of x. So, take note our numerator, 3, is greater than 0. Right? And then, let's find out the denominator. Take note our denominator is here, is x plus 2. Tapos, our a is negative 2. Tapos, a is from the left. So, we got less than negative 2. We got negative 2.01. That is, will be our value of x. So, mangita ra kag value ni x nga nasa left side, kanang closer. So, equals negative 2.01 plus 2. So, the answer is negative 0.01. And take note that is less than 0. Therefore, our g of x approaches 0 from the left. So, atong balikon sa Theorem 1.4.2, ang atong c is greater than 0. and then our g of x dito is from the left of 0, or g of x approaches 0 from the left. So that is negative. So here, therefore, we got negative infinity. Okay, in this side. So we get negative infinity. So baliktad dire, we got negative infinity, tapos we have 2 over 3. Balik ta sa last theorem, negative ang atong f of x, tapos RC is greater than 0. So here, so we got negative infinity. So the limit is negative infinity. Alright. So that is our lesson about infinite limits. So just check, study further about the theorems, and familiarize how they are used in the different expressions. And take note, there is no shortcut to master these things. You need to do some practice.